So hello and welcome my dear students in my channel A Journey with Physics where quality matters. So again I have come in front of you to take another class with you. So this time the class will be taken from the C Verma Solution on volume 2 and the chapter will be 32 and the chapter name is the electric current in conductors. So there are 5 parts have been uploaded and the link of those classes are given in below in the description box or in the first comment section. You can visit and you can watch those classes because the solution from C Verma is a magical one, because you know, all of you know, the C Verma book is a very much fruitful book and it is a very much essential book for your concept in physics. Okay, so another you can say the beauty of the physics lies in the C Verma book, or you can find the beauty of physics, how much physics is there. The C Verma book consists of it. So we are trying to give you some solutions or exercise solutions which helps you to crack in JEE Main or NEET exam. So in 5 lectures, in the previous 5 lectures, we have completed 14 problems from exercises, which the page number of 198. Now today we will start doing our problem from 15 number from 15. Okay, so don't waste any much time. Now focus on the question. Just focus on your screen. And what does the question say about this problem? The problem is the current. The problem says that the current in a conductor and the potential difference across its ends are measured by an ammeter and a voltmeter, and the meters draw negligible current, and the potential that is a potential measurement instrument, that is a voltmeter, has a zero resistor, has a zero error, that is it does not read zero when no potential difference is applied. And there are 2 given cases. Calculate the zero error if the readings for the 2 different conditions are 1.75 ampere and 14.4 volt. Another condition is 2.75 ampere when the applied voltage is 22.4. So the condition is, if you read very carefully this problem, you will able to understand that the voltmeter is not perfect but the ammeter is perfect one. That is, ammeter has zero resistance and the voltmeter has some resistance. That's why when there is no potential difference across the circuit, but it has some readings. But in case of ammeter, there is no reading. Okay, so we have to find that reading. We have to find that reading of voltmeter when there is no potential is applied in the given circuit. Okay, so you can consider a conductor as a resistance because the conductor has itself in its own resistance, right? So you can apply the battery here. And you know the ammeter is connected in a series and the voltmeter is connected in parallel with the given resistance. Okay, so now there is 2 conditions. Number 1 condition, when the applied voltage is 14.4, the current is 1.75. When the applied voltage V1 is 14.4, the current I1 is 1.75 ampere, and when the applied voltage V2 is 22.4, I think 22.4, the current goes to 2.75. The current goes to 2.75. Okay. Now take the reading for voltmeter. that is when there is no potential, that is the zero error. Means if there is no applied source in the given circuit, the voltmeter has its own reading. Okay, so now take the reading of voltmeter as V, which is zero error. Which is zero error. So from the given condition we can write so V1 minus of V equals some current into resistance I into R, and that resistance will be the resistance of the conductor. And again from the given condition V2 minus of V, some current into resistance, and that resistance will be the resistance of the conductor. And if you divide this two, V1 minus V in the denominator part V2 minus V, and that is I1 by of I2. Now I1 is 1.75 and I2 is 2.75. And now for V1 you should put the value of 14.4 minus of V, and in the case of V2 you put the value of 22.4 minus of V, and 1.75 and 2.75. And now the duty is yours to solve this given expression, and you should find the value of V, which is exactly the given answer, which will be the given answer. So okay, I think you have understood this problem. So this potential V is the zero error for the voltmeter. That is when there is no potential, it has some potential of the voltmeter due to its own internal resistance. Okay, so now moving to the next question, and the next question is 16 number question. So I can erase it and moving to the next. So this problem is of 15 number, and now we will move to question number 16. Now we move to the question number 16. So what does the question say? The question of 16 number says actually, here is in our screen, it has some figure and some statement like a paragraph. So the given question, the figure shows an arrangement to measure the EMF, that is of some EMF given, that is of E, and the internal resistance R of a battery. The voltmeter has a very high resistance and the ammeter has some resistance too. Okay, the voltmeter reads 1.52 volt when switch AC is open. When switch AC is open, and when the switch is closed, the voltmeter reading drops to 1.45 volt and the ammeter reads is about of 1 ampere. Find the EMF and the internal resistance of the battery. Okay, this is a very easy problem and a very conceptual problem at the same time. You have to find the two questions. You have to give the two answers from this question. One is the EMF and another is the internal resistance of that EMF or that battery actually. The figure, so I have to draw the figure. The figure actually, here this is the voltmeter and here a switch S and a ammeter is there. So I have to draw very carefully. Okay, now two conditions are given. So in this also internal resistance is also shown. Now we have two conditions. When edge is open, the voltmeter reading is 1.52. Voltmeter reading is 1.52. That's fine. And when AC is closed, the ammeter reading, that is of current, is of 1 ampere, and the voltmeter voltage decreased to 1.45 volt. Yes, definitely 1.45 it has. So you have to find the EMF of this battery, and you have to find out the internal resistance also. You have to find the internal resistance also. Now what you will do first? So now, to find the EMF of this battery, you have to apply some concept, because when AC is open, that is when AC is not closed, that is AC is open, no current will flow through this circuit, because the circuit is then an open circuit, and we know very much well the open circuit cannot grow any current. That is, in reverse we can say the current cannot flow through a open circuit. To flow the current we need a closed circuit. So when AC is open, the circuit is open, then the current is not, the current has no value. That is, the current is not flowing through this circuit. That means the total EMF will be same as the voltmeter reading. Got it, my words? So the amount of voltage drops here is equal to the voltage consists of the EMF. That is the EMF. So we can easily say when AC is open, the EMF E and the voltmeter voltage is equal. That is, the value of the EMF will be 1.52 volt. So the EMF of the battery will be 1.52 volt. Now the case number 2, that is the second case, when AC is closed. Now when AC is closed, a current will flow from this path. Okay, the current will flow from this path, and here the reading of the current is I equals to 1 ampere. And you know a very much formula. That is the voltage drop across these two ends of the battery. V prime is equals to EMF minus current into internal resistance. You know the formula very well. Got it, my words? When AC is closed, a current will flow, then the voltage across this resistance or the two terminals of the battery decreases below actual the EMF supply. So that terminal voltage is given, that is of 1.45 volt. So you can put the value of 1.45, and the terminal voltage is here, and the EMF of the supply is 1.52, and the current is 1 ampere, and R is internal resistance. So internal resistance is 1.52 minus of 1.45, that is of 0.07 ohm. 0.07 ohm. This is the value of the internal resistance, and this is the value of the EMF of the battery. Okay, got it, my words? So this is very easy problem. Very easy problem. Again, we will move to another easy problem. That is the question number 17. So I can remove it. Now moving to the next one. Now I'm going to the next one, and the next question says that here is on your screen the potential difference between the terminals of a battery of EMF 6 volt. The EMF of the battery EMF of the battery is 6.0 volt, and the terminal voltage, that is the potential difference between the terminals, and the internal resistance 1 ohm drops to 5.8. so here the value of the potential across the two terminals, or the external resistance, you can say, when connected across an external resistor. So external resistor across, say, when the battery is connected, then the potential across the external resistance drops to 5.8 from 6. So the loss of voltage is how much? The loss of voltage is of 0.2 voltage, and this is the due to the internal resistance. You know this. Find the resistance of the external resistance, and you have to find out the R value, the value of R. And so how we can do this? How we can do this? You have to find out the current. You have to find out the first current, and you know the value of the current. How you can do this? Yes, from the, you should remember the formula. Potential across the external resistance is equal to the total EMF of the battery minus of the internal resistance and the current multiplication formula. So put the value of V 5.8, E6, that is of I into smaller, and smaller is equals to 1, that is I is something 6 minus of 5.8, that is of 0.2 ampere. So the value of the current flowing through the circuit is of 0.2 ampere, and you know the value of I is E by R plus of R plus R, smaller, and I is of 0.2, E 6 volt, R is unknown, and the smaller is known, that is of 1. So R plus 1 equals to 6 by of 0.2, and that is of 30. That is of 30, I think. So here goes 10 to 330. So the value of R is of 29. So the value of the external resistance, that is of capital R, is of 29 ohm. And if you want to know the figure, then I can draw in this fashion, smaller, and this is of E, and this is the voltage V across the external resistance. Okay, so you know very much how we'll schedule these classes, because every day I will try to solve 2 or 3 problems with just a couple of minutes, or not just couple of minutes, within some 20 minutes. I would like to now end up my session. So next day, I will come with some beautiful problems from C Verma. Okay, that is of volume 2. Tata.